Welcome to this module where we are going to discuss about API and API Gateway. Before we discuss about API and API Gateway, it is important to understand what is serverless computing. Right? So we would be discussing about serverless computing, and then after we would be starting with API and API Gateway. So this is the content of this particular module. We will understand what is serverless, and then we'll be going with API Gateway. So into the serverless, we'll be discussing about what is serverless computing and what are the benefits of using serverless computing. So let's get started with this. So very first thing that we have to understand over here is serverless computing is a cloud computing model which offers us to not manage the infrastructure. Okay. So the cloud provider would be managing the infrastructure and it will be automatically allocating the resources as required. So we do not have to worry about availability, scaling, servers, nothing at all. Okay, underlying infrastructure, we won't be knowing anything about underlying infrastructure. We are not responsible for that, as well as we do not have any control over that. So we have discussed about Lambda. So Lambda is a serverless compute, right? So we don't know that what infrastructure is running in the backend. We just have to upload our code and we can run our code on Lambda. Most of the time, the serverless computes or the serverless computing is event driven. Event driven means when something changes, when something happens. At that time, the serverless compute would come into the picture or it would be triggered. So it is triggered by events. It can be any kind of event, HTTP request, database updates, file uploads. So we have already discussed about this. Like if something is changing into S3 and if I want to react to that event, then I can create one event notification for the same. Right. So event notification would be created for any changes into S3. And what will happen here is from S3, I can trigger Lambda function. Lambda would do the processing and then it can again send the result to any of the AWS service, like let's suppose back to S3. So these are few of the examples of serverless computing: Lambda, S3, API Gateway, DynamoDB, etc. So there are many services that are serverless on AWS. So this is the example I was talking about. If user uploads any of the file, let's say JPEG files are being uploaded in the S3 bucket, then I want to convert this JPEG file to the thumbnail size. So I can just put the code in Lambda. Suppose that code is in Python, then I would be using the Pillow library to manipulate my image. And where I'll be getting this image from? Because the Lambda function is triggered by the event. Okay, so we understood already that we have a Lambda handler function. So this Lambda handler function would be having two parameters, one for event and another one for context. So we can get the details of the bucket and the image from this event object. We would be converting that object into the thumbnail size. We would be reducing the size of it and we will be again uploading it back to S3. Here IAM permissions should be in correct order or they should be given to the Lambda function and the S3 so that Lambda and S3 can communicate with each other. So what are the benefits of using the serverless computing environment? There are several benefits like reducing the operational cost. So whenever we go with serverless, it is truly pay per use. Truly pay per use model. Because in EC2, it may happen that if you are EC2 instance is running idle, then also you are being charged for that. But here it doesn't happen like that because your resources will get triggered only when some event happens. So you pay for the actual usage of your functions and you don't have to manage any servers or infrastructure. The next benefit is increased scalability and availability. So AWS manages the scaling and availability of serverless computes. So you do not have to worry about scaling and making your environment highly available. Like in EC2, if you want to make your environment highly available, then you would be deploying your EC2 instances into multiple AZs, right? And for scaling, you would be creating your auto scaling group, right? Auto scaling groups would be created. And to distribute the load between the instances, you would be then having your application load balancer. So this infrastructure will become quite complex infrastructure. So instead of that, you can go with the serverless computing so that scalability and the availability is automatically handled. You don't have to do anything for that. The third advantage or benefit can be faster time to market. Because you are not worried about the underlying infrastructure, you can put that time for developing and deploying serverless applications. So you would be deploying at the faster rate and that will accelerate your time to market. The Lambda function or any serverless service that you use on AWS can integrate with other AWS services. Like you can go with you can connect your Lambda with S3, you can connect your Lambda with SQS, you can connect your Lambda with DynamoDB. So integration of Lambda or any service with any other AWS service is quite easy when you are using your serverless environment. So these are few of the benefits of using serverless technique. The next topic that we are going to discuss about is API gateway. So before discussing about API gateway, we need to understand that what is API, what are the different types of API, and what is API gateway, and lastly the features of API gateway. So API stands for Application Programmer Interface, and we have to understand what basically is use of API. So here again you would be finding a lot of analogies for understanding it better. So if we see over here types of API, then we would be discussing three types of API in this module. It would be HTTP, REST, and WebSocket. These are the three types of API that we would be discussing over here. So let us understand what is API. So API is nothing but application programming interface. So it is a set of protocol and routines and tools for building software applications. The API is becoming popular because of the microservice architecture and the modularity that we are trying to find into today's application. Because they allow us to create the modular, reusable, and interoperable software components. So we have discussed into the microservices that we have different microservices, like one microservice can be dealing with logins, right? Other can be dealing with the profile, and then the next can be dealing with your orders. So if all of these microservices are created and if they want to communicate with each other, then we need some mechanism. So that mechanism is APIs, right? The example here can be a very common example. Let's say that you find the option of pay with PayPal or pay with Google Pay or pay with Paytm on many e-commerce websites. So those e-commerce websites, what would have they done? Would they have, taken the entire code of Paytm and would have kept on their website the code? Obviously not, right? So they would have just used the API for Paytm or API for Google Pay, API for PayPal, and they would have called that particular API from their application to use the functionalities of the third party softwares. So you can think API as the restaurant menu. Okay. So the menu is the interface that allows customer to order food from the kitchen. So just like that, an API is interface that allows developer to interact with the software system. Menu will provide list of items that customers can order along with the description and price. Similarly, API provides a list of available actions. So this is what the API is. Now there are three different types of API, that is REST API, HTTP API and WebSocket API. Let us understand what are these three and what is the difference between two with the help of one analogy again. So HTTP API, as HTTP stands for Hypertext Transfer Protocol, right? So two applications or two systems would be communicating with each other using this protocol, HTTP protocol. So HTTP APIs make endpoints available as API gateways, allowing the HTTP queries to connect to a server. So the example here can be when you are scheduling your Zoom meeting on your Google Calendar, okay? So you are actually utilizing your HTTP API. Instead of copy and pasting the meeting invite into the field, the API explains how Zoom may communicate directly with the Google servers to embed a Zoom meeting within the event. So this is one of the example of HTTP API. Then we have REST APIs, that is Representational State Transfer Application Programming Interface. It is data source front end that allows you to create, retrieve, update or delete any kind of data items when you are using it with your code. So this is popular in microservice architecture. So REST API is a set of HTTP based standard API. Basically, it is, providing more functionalities than that of HTTP APIs. So along with the REST API, we have four basic methods that we can use like post, get, put and delete. If I want to create a record, I'll be using the post verb. If I want to read the data using the REST API, then I'll be using get verb. If I want to update a record, I'll be using put, and if I want to delete a record, I'll use delete. So whatever operation you want to do while calling that API, you have to define that using these verbs. The next topic is WebSocket API. So WebSocket API is useful when you want the bidirectional communication between a client and a server. So HTTP and REST, they are not long-lived connections, but this is a long-lived connection. So when you want to design real-time low latency web applications or chat applications, in that case, WebSocket API would be useful. Because in the chat application, what we would want that both way communication should be happening, right? And the connection, we should not be opening the connection again and again with the servers. It should be long-lived connection. So that's where WebSocket API would be helpful for us. It is built on the TCP/IP stack and it provides full duplex, low overhead, low latency transport mechanism. It can exchange various types of data such as text, binary or JSON, and it is secured using these encryption methods like secure transport layer, security, and SSL. Right. So now let us understand the difference between all these with the help of one analogy before we go to API gateway. So let me just put one new slide over here. Let's have this blank white screen. So we have to understand the difference between all these three APIs in a very simple way. So for that, we would be again going to our restaurant and we'll try to compare all these three APIs with the different components of restaurant. So we have HTTP, we have REST, and we have WebSocket. So HTTP can be compared with waiter, who takes order from the customer and brings them back the food. What happens over here is the customer can only place one order at a time and they have to wait until order is fulfilled before placing another order. So similarly, the HTTP client will send requests to the HTTP servers which respond with data or action. HTTP requests and responses are sent over a stateless connection, which means that the request response pair is independent of each other. So here, unlike WebSocket API, we do not have long-lived connection and we do not have duplex method. For REST API, you can compare this REST API with menu. So REST can be compared to a menu in a restaurant that will list all the available dishes and their ingredients. The menu provides a standardized way for customers to browse, select, and modify the dishes they want based on their preferences and constraints. Similarly, REST API provides a standardized way for clients to access and manipulate resources based on representations and relations. So REST API, as we know, uses the HTTP methods such as get, put, post, and delete. It also performs these methods are used for performing CRUD operations on resources. And it uses URIs to identify and navigate the resources. Now, the last type of API that we discussed is WebSocket. So, WebSocket API can be compared to a phone line in a restaurant that connects customers and chef directly, allowing them to talk to each other in real time. Customers can ask questions, they can provide their feedback, or request modifications to their orders, and chef would be responding immediately without having to wait for next order. Similarly, WebSocket API is a bidirectional, persistent, low latency communication channel between client and servers. It allows them to exchange the data and events in real time. This is really very important for some kind of applications that require real-time interaction, such as chat rooms, online gaming, or stock trading. So these are the three different types of APIs. I hope that it would be much clear. The difference of these three would be now much clear for you to understand. So the next topic that we have to discuss over here is API gateway. So we have discussed what is application programming interface, but we need some tool, right, for creating those APIs. So that tool provided to us by AWS is called as API gateway. So API gateway is a fully managed service that makes it easier for the developers to create the APIs. It acts as a front door. Even if you see the icon of API gateway, it is something like this. So it acts as a front door entry for connecting to the backend services. API gateway will allow you to define and enforce policies for authorization, authentication, and access control. Apart from that, you can also filter your request by using the API gateway. If you think that some of the headers or some of the query string parameters should be compulsorily available when the API call is made, but if they are missing from the API call, then the API gateway will discard that request then and there. It will not even hit your backend. If some specific values are required for some headers, and if that API call is not having those values, then in that case also your API would be discarding the request then and there. So it is useful in serverless and microservice architecture, because in microservices we would want all our services to be called from a unified front end instead of making individual call to all microservices. It would be difficult to manage in that way. So if we want a unified front end, then this is a really very good tool or a service to use. API gateway will support all three APIs that we discussed, that is HTTP, REST, and WebSocket. Do we have just 3 types of API? No, we do have other APIs as well, but we are not discussing those APIs for scope of this course. So what are the features of API gateway? So if we talk about the features, then first of all, we get the unified front end. That is, all the requests which are coming would be first coming to the API gateway, and then we would be going to the backend services. It increases the security because API gateway would be supporting various authentication and authorization mechanisms such as IAM, Lambda authorizers, or custom authorizers. It can also integrate with AWS Certificate Manager to provide SSL, TSL certificates for secure communication. It can also discard the bad requests, and it will not take your request to the backend. It provides us with the scalability. So API gateway can handle large amount of traffic, like millions of requests can be handled by API gateway. It can automatically scale your APIs to handle any amount of traffic and distribute the traffic across multiple endpoints for higher availability. The other important aspect is monitoring and logging. So API gateway provides real-time metrics and logs for your APIs, such as API usage, error rates, latencies, or request response data. You can integrate your API gateway with AWS services. So because it is making the backend call, obviously it should be integrating with the different AWS services, right? So the integration can be done with AWS Lambda, DynamoDB, S3 to build serverless application and microservices. The other advantage over here is you can create your own APIs and you can publish them to market. Like you can provide other customers to use your API. So when you do that, you can also monetize your APIs. And you can decide that which customer would be having what limit for calling that API. Okay, because or else your API will get overwhelmed. So you can decide on the limits that, okay, customer A can make 1000 calls per second to this particular API. So you can also throttle the requests of customers if you want. So in conclusion, we can say that API Gateway is a powerful and flexible service which will allow you to build, deploy, and manage APIs at any scale and complexity. By using API Gateway, you can secure, monitor, and scale your APIs easily, and you can integrate them with AWS services to build modern and efficient applications. So this is one sample architecture that whatever request comes would be first coming to the API gateway. And in the backend, suppose we have different Lambda functions, then those Lambda functions can be handled something like this, like Lambda function for order. So the API gateway would be going to the Lambda functions for order by using the resource path. So there would be the resource path for order. There would be resource path for product. There would be resource path for payment. So API calls would be made accordingly to this path, and we are actually protecting our backend as well over here. So security is being increased. All the requests would be first coming to the API gateway and then it would be going. So we are not exposing our backend services directly. So this can be one added advantage of using the API gateways. So now that this is being understood, what we can do is we can just try to have some demonstration on the portal to understand API gateway in a better way. To understand that how we can create the API gateway, and also we have the testing capabilities then there itself on the portal. Okay, so let's not waste any time and let's get to the portal and see how to create the API gateway. Okay, so I am on my AWS console. So we want to build the API gateway. So I will just search it from here. Let's say API gateway, build, deploy, and manage your APIs, right? So we'll be going here in the API gateway console. So we can get started. Okay, let this load. Perfect. So we have the APIs over here. I'll be creating the REST API, right? So we can just click on build here. If you want to import, you can also import your APIs, but I'm going to build it. Okay. Now I'll be going with the example API. So we are creating the REST API and I'll be creating the example API. I don't want to create any new API. I don't even want to import it from Swagger. Swagger is one tool for creating your APIs. Okay. So this is your API. As you can see over here, this is how it is being written into the JSON format. So I will just go and it would be the regional endpoint. What is required? Do you want to fail on warnings or do you want to ignore the warnings? So if any warnings occur, then the API call would fail. Okay, I will do that and let's import this particular API. Okay, so your first API is fully populated from the pet store Swagger template. You can now deploy your API to see it in action. Feel free to click around the console and follow the hints. Right. So our pet API is being created. We can deploy it as of now. So if I am deploying this API, it will ask me that to which deployment stage you want to deploy this API. So different stages can be there, right? Into the production, we can be deploying into the testing or development. So those are the deployment stages. And you can be using different APIs for your different environments, and you can give here a new stage and deployment description. But as of now, I will cancel this. So you can see over here, we have a get, which is a mock endpoint, which is created. So if I just go inside of this get method, you will see that we are having method request, we have integration request, we have integration response, and our method response. So these are the four major components of creating the API. Okay. Method request, if we see the method request, it is the component that defines how the client's request is transformed before it is passed to the backend services. So it will basically include the settings for headers, for query strings, path parameters. You can also specify validation rules, such as if some field or data type is being required, okay, then you can do it under request validator. You can provide any kind of authorization if required, right? You will be seeing the URL query string parameter. Do you want any query string parameter as required? Okay, if that is not there in the API call, then it would be discarded. You can set here the HTTP required headers. You can say what is the request body, what should be the type of request body, what is the content type that you want to add it over here. So all of these things can be added over here, and this basically provides you the settings for authorization and validation, right? So this is the first important component. The next important component is integration request. So this component defines how the client's request is transformed before it is sent to the backend service. So it includes settings for integration type, like how do you want to integrate this? Do you want to integrate it with HTTP? Do you want to integrate it with Lambda function, with any other AWS service, or with the mock integration? So if you see, it returns the response purely using the gateway mappings and the transformations. Now, what are mappings and transformations? If you are putting your request in, okay, the body is coming into the JSON, the request body, but the backend is expecting XML. So that transformation can be applied over here, right? You can have these mapping templates as well. Right now, we do not have any mapping templates, but you have these three options where request body pass through. You can be defining your request body pass through. So we will be going back to our next component. That component is integration response. So this component defines that how the backend service response is transformed before it is sent back to the client. So now it is the opposite way, okay? These two, method request and integration request, these two deal with how the transformations are to be done when we are contacting backend service. Now here it will suggest that how the transformations are done when we are sending our response back to the client. So it will include settings for mapping the resource payload headers status code to the API gateway response format. So we have the status code 200 and default mapping is what we are using. You can add other integration response, like what will happen if we get 404, what will happen if we get any other response status. So this component will also specify error handling and retry settings. Okay. The next is method response. So this component defines that how the backend service response is transformed again before sending it to the client, and it includes the settings for header, response models, validation rules. These components can also specify error handlings and core setting, that is cross-origin resource sharing. So here you can add any response. We just have 200 response status code, right? But if you want, you can add any other response as well. But in this demonstration, we are not doing that. I'll go back. And this is our entire, these are all the components that we have. Okay. This basically defines the behavior and the transformation of request response. Now I want to test this particular API, so I can test it from here, right? So you can see we will be just clicking on test. So you can see we have this response. So status code is 200, latency was 4 milliseconds. And we got this result over here when we tested the API. Right, these are all the logs. So what response we are getting? We are getting the response as welcome to pet store. You have successfully deployed your first API. So this is basically working fine, right? That was just the testing part, right? It was just showing the result here itself in the portal. But what if I want to see the result on the browser, because we are making the API call, right? So it should be working from a browser as well. So we have two methods over here, get and post. So I go to get over here. When I go to get, I get this particular URL, as you can see. So we can be using this URL and we can be pasting that onto the browser tab and it will open up. Okay, so just a minute. So I'm here on this resource part. So that is pets, right? When I just try to copy this entire thing, it will copy the entire URL, though it is not showing. So let me just delete this and I will paste this. Okay, it is not doing that. Let's have this one. So this is the URL, petstore.executeapi.us1 Amazon AWS.com petstore/pets. Okay, petstore is the name of our API and pets is the resource path that we have. So let's just try to execute this one. So this is what we get when we are using this particular API. Right, it gives us the details about all the pets that we have. Now, if I want to get the details about a specific pet, then what to do? So I can add one more thing over here, that is pet ID. Let's say 1. Okay. So if I just run this API call, then I'll be just getting the details about the pet ID 1. So why this is working? Because we also have one get option over here for pet ID path, right, which is under the pets. So this is how you can actually work with your API gateways, right? We do also have the option of post over here. As you can see, we have post, right? So if I just go to post and let us test it locally here, I'll test it here and we have to give the pets detail and the header, right? And we have to give the request body as well. So over here under the request body, I'll just put this for the result, the turtle type, the pet type would be turtle, and I'll just change this price. Once I've done it, I can simply test it and you can see that it is successful. 12 millisecond was the latency and this is being added over here under pets. So this is how you can test your APIs using, locally, or you can also go here and you can make the API calls from your browser. So this was the simple demonstration for API gateway where we are just using the sample API, but you can create your own APIs and you can be using that as well. You can be defining those 4 components: the method request, integration response, and method response. Okay. So this was all for the API gateway demonstration. So let's just go back to the slides and understand that what all things we have discussed in this module so far. So in this module, we discussed about serverless computing, that what is serverless computing and what are the benefits of that. So we understood that serverless computing is nothing but a type of cloud computing where we do not have to maintain the infrastructure. It is being maintained by the cloud service provider, that is AWS, and we don't have to worry about infrastructure scaling, high availability. We just have to worry about our code or the data that we want to put on the serverless services. So different serverless services on AWS are Lambda, it can be S3. Why S3? Because in S3 also, I'm not saying that how much of storage is being required. Okay, it is scaling up and down as per the objects that I'm storing. It is making it highly available by default. By using different storage classes, I can have my data into 3 availability zones. So that's why we are considering S3 also as serverless. Then we have DynamoDB, we have Fargate. All of these are the serverless services offered by AWS, where we do not have to maintain the servers or underlying infrastructure. The next topic that we discussed about is API. That what is application programming interface and how it is useful for us. We discussed about 3 different APIs, that is HTTP. Then we discussed about REST, that is representational state transfers. And then we discussed about WebSocket. We also saw an analogy where we discussed that HTTP can be considered as a waiter who would be taking the request from the customers, and customer have to wait before ordering any other thing. Okay, so if the first order is being served, then only the next order can be taken. Then the REST API, it was all about comparing this REST with menu. So into menu, we have different items listed along with the descriptions and the price. The same thing happens over here in the REST API also, using the resource path, that to which path we want to cover. Into our demonstration, we saw that pets was one of the path and pets ID was another path which was under this pets. Right, so pets and pets/pets ID. And for this also, along with the resource path, we have to give the HTTP method that we want to use. That do we want to get something, do we want to post something, do we want to put something, or do we want to delete something. So these are verbs that are used with REST APIs. So along with the resource path and these verbs, we can create our REST API calls, right? Then we have the WebSocket API, to which we compared it with the phone line. So what happened into this is we understood that it is a duplex thing. So it is very important for chat rooms or gaming, or say for stock trading, where two-way communication is really very important and we want the long-lived sessions. So at that time, WebSocket would be important for us. So this was about the APIs. Then we started with Gateway API, or say API Gateway. So we understood that it is a front door for all the API calls that we want to make to the backend AWS services. So because this is a front door, it allows us to secure our backend services, because all this request would be first coming to the API Gateway. You can create your own APIs, you can monetize those APIs, you can create different plans that if you are monetizing your API and making it available for other customers, then you can say that those customers, how much API calls or how many API calls they'll be able to make. Because if you allow them, unlimited API calls, then your API gateway will be not able to handle those requests, will get overwhelmed. So we have to throttle the request. We have to put the limits over there. API gateway will support all of these 3 APIs, REST, HTTP, and WebSocket, right? Then we discussed about into the demonstration 4 components of API gateway. That was method request, integration request, then we discussed about integration response and method response. So these are the different ways in which we can map to different services that we want to call with the help of that API. We can create the validations, we can create the authorizations, we can create the authentications using all of these different components of APIs. So these are all the things that we have discussed so far into the module API and API gateway. So that's it for this particular module, and we are good to conclude this over here. So thank you everyone.